Good afternoon, everyone. My name is Jaimron, and I'm excited to be here today to present my project on credit card fraud detection. A little about myself. I am currently studying cybersecurity in my fourth year of college, and I have always been interested in how technology can solve real world problems, especially in areas like cybersecurity, machine learning, and data analysis. Now, with more and more people using credit and debit cards for daily transactions, the risk of fraud is growing at an alarming rate. Every day, cybercriminals are finding new ways to exploit vulnerabilities in payment systems, and billions of dollars are lost globally each year because of this. That's where fraud detection systems come in. My project dives into how we can build intelligent systems that not only detect fraud, but learn and adapt over time. I will be talking about how techniques like genetic algorithms, behavior based analysis, and hidden Markov models can be combined to recognize suspicious activity and prevent financial losses. Now, I will walk you through how such systems work, the core concepts behind them, and how machine learning plays a key role in analyzing and responding to potentially fraudulent behavior. I will also briefly discuss how students and aspiring professionals like us can explore this area further, whether through coding projects, database, or cybersecurity research. So, with that said, let's get into the presentation. All right, the abstract. Let me start with a quick overview of my project. Credit card fraud detection is a critical issue in cybersecurity and finance. Every day, thousands of people face unauthorized transactions, sometimes small, sometimes catastrophic. The real challenge is that fraudsters are constantly changing tactics, so we need systems that can adapt, evolve, and spot patterns even when they are subtle. To do this, my project combines three powerful approaches. Genetic algorithms, which are inspired by natural evolution, help us automatically discover the best fraud detection rules by simulating selection, mutation, and crossover. Behavior-based techniques analyze how a user normally behaves, things like how often they log in, how much they usually spend, and where they make purchases. Hidden Markov models, or HMMs, are used to model and predict sequences of events. So, if a transaction deviates from the expected pattern, it raises a red flag. Together, these techniques help us go beyond simple rule-based detection to something much more dynamic and responsive. Now, the aim for this project, the goal of this project is to develop a smarter fraud detection system, one that can monitor transactions and user behavior in real time and take immediate action if something suspicious is happening. Now, that's going to include identifying unusual login behavior, for example, logging in from a new country or any odd time, flagging transactions that don't match a user's regular spending pattern, like suddenly buying expensive electronics from a different IP address, or sending real-time alerts to the real user, allowing them to confirm whether the transaction was legitimate or not. The system also blocks or pauses any questionable activity until it is verified, which gives users more control and security. And it also, and of course, all of this has to happen without compromising the user's private data. So, security and privacy are built into the foundation of the system. Now, as for why credit card fraud detection matters, credit card fraud detection is not just important, it's essential. Every year, credit card fraud costs the global economy billions of dollars, and the numbers are rising as online shopping becomes more popular and digital wallets replace cash. It's no longer just banks that need to worry about this. Any platform that processes payments, from e-commerce websites to rideshare apps, is a potential target. Now, but here's the thing. Fraud is often hard to catch in real time. By the time a person realizes their card has been used, it may already be too late. That is why fast and intelligent detection is crucial. We need systems that act immediately, not after the fact. It's about stopping the damage before it happens and making users feel like their information and money are safe. This sense of trust is vital for any financial system to succeed. How does it work? Well, so how does the system actually work? At a very high level, it continuously monitors actions, not just transactions, but also logins, device changes, location shifts, and more. This builds a behavior profile for each of the users. If anything happens that falls outside of the normal range, for example, if someone logs in at 3 a.m. from a different city and immediately tries to transfer money, the system flags that as suspicious. At this point, a few things can happen. An alert is sent to the user, typically via text or email, asking them to confirm whether they recognize this action. The system may block the action temporarily or deny access to the account until verification. All of this is logged for further analysis and to improve the model. This kind of behavior-based response is much more flexible than using some hard-coded rules which fraudsters can eventually work around. All right, techniques used. Now, let's talk about the three main techniques used in this project. First, genetic algorithms. These are optimization tools inspired by natural selection. You start with a population of potential solutions, in this case, detection rules, and then simulate the process of evolution. The process rules survive, combine, and mutate, and over several generations, you get increasingly better fraud detection strategies. This is great for discovering new patterns or thresholds that a human might not even think to define. Next, we have the behavior-based detection. Instead of hard rules like block all transactions over $1,000, we look at how the user typically behaves. If they always spend $20 on groceries and suddenly out of nowhere they buy a $2,000 gaming laptop from another country, that behavior really stands out. It's a more personalized, adaptive approach. Now, lastly, we have the hidden Markov models. These are statistical models that look at sequences of events. So, for example, if your normal behavior is to log in, check your balance, and pay a bill, and suddenly there's a login followed by a big money transfer, the model can see that the sequence doesn't fit your usual pattern, and they can flag it. Now, machine learning and fraud detection. Machine learning takes this system to the next level. The idea is to train a model using historical data, where each transaction is labeled as either fraudulent or legitimate. Using that data, the model learns what features are common in fraud cases. Things like unusual times, IP addresses, mismatches, or even high transaction values in unfamiliar locations. Once trained, the model can analyze new, unseen transactions and make real-time predictions, and this is likely fraud or not. Now, over time, the model. Hold on. Now, over time, the model improves. It learns from user feedback, like if the user marks a flag transaction as legitimate or catches one that wasn't blocked. This feedback loop helps reduce false positives and increase the accuracy of the model. Common tools used here to include um, Python for coding the logic, uh, scikit-learn for basic ML models like decision trees or random forests, TensorFlow or Keras for deep learning models if the dataset is large or complex. And yeah, this approach really helps to create a system that evolves along with new fraud strategies. Now, as for the system flow, for the system workflow, here's a visual representation of how everything ties together in the system. Firstly, a transaction is initiated by the user. The system collects data like the transaction amount, the location, the time, the device ID, and then it compares it to the user's known behavior. This data is passed to the trained machine learning model, which makes a classification, which is typical behavior or potential fraud. It then looks if it looks suspicious, the system sends an alert to the user. It will block or delay the transaction. It will log the incident for analysis, and if it's legit, it simply allows the transaction as normal. It all happens in real time within milliseconds, and the goal is to catch fraud before it impacts the user or the institution. Now, what can aspirations do? One of the great things about this project is that it's an area where students, aspiring data scientists, and developers can get involved right away. You can start by exploring real datasets like the one on Kaggle that contains anonymized credit card transaction data with fraud labels. It's a really, really great way to learn fraud patterns, like learn how fraud patterns look in practice. You can also build your own ML models using classifiers like support vector machines or SVMs, decision trees or random forests, or even neural networks if you want to go deeper. Python is the go-to language here. And it takes tools like Jupyter Notebooks, Pandas, and scikit-learn to make it easy to build and test models. This area is also great for anyone interested in cybersecurity, AI ethics, or digital finance. There are research opportunities, career paths, and even startup ideas related to fraud detection. Now, in conclusion, credit card fraud is a very, very serious and growing problem. It's also one where technology gives us powerful tools to fight back. But by combining intelligent techniques like genetic algorithms, behavior-based analysis, and machine learning, we can build systems that not only detect fraud quickly, but actually adapt over time. These systems protect users, reduce financial losses, and build confidence in digital transactions. This project has really, really shown me how important it is to create tech that not only works but protects people. It has opened my eyes to how much potential there is in using AI and data science for real-world security applications. Thank you so much for your time, and I'd love to hear your thoughts or answer questions you might have regarding my project. Thank you. Have a great day.